Okay, let's have a look at some hints for the homework sheet WW2. First question, you have to write that in the form P bracket x plus q all squared plus r. In other words, complete the square. So the first thing we need to do is we need to try and get this value of p there. And the way we get the value of p is we take a common factor out the first two terms. So 2 goes into 2 and it goes into 12. So that is going to be my first stage, to take 2 as a common factor. Once you've got 2 as a common factor, you can then do the little square bracket. Remember how we get this number here at the end is we look first of all at this number, we square it, we then multiply it by 2 and we ask how do we reach 13, and that's the number that goes in here. Second question, the recurrence relation. Now, the recurrence relation, which we're given as un plus 1 equals a un plus b, if I put some numbers in there, that means that u1 is equal to a times u0 plus b. It means that u2 is equal to a times u1 plus b, and so on and so on and so on and so on. Now, fortunately for us, the question tells us what u0 is. It tells us that u0 is 4. So I'm just going to plug that in there. So my u1 actually becomes a times 4, or 4a, plus b. Now, the question's asking, what's u2? So I'm now going to take this expression here that I've got for u1, and I'm going to plug that in there. So I'm going to end up with a times that expression, plus b, multiply it all out, tidy it up, you've got your answer. Question 3, a log question. So log to the base a of 64 is 3 over 2. So how do I get rid of the log? The way I get rid of the log is to make a power. So a to the power 3 over 2 equals 64. Now that in itself is quite a complicated thing to try and actually solve. However, if you remember from your laws of indices, then a to the power 3 over 2, this part here, this power is actually made by doing a to the power a half to the power 3 equals 64. Why am I doing that? Because I can then write a to the power a half equals the cube root of 64. Once you know what that is, we can then work out what a is. There's a few ways to get to that answer, guys. That's not the only way, but it's one way that works. You can use that one, or see if you can find your own method. Question 4, probably the easiest one that's actually there this week. F of x equals 4x cubed minus x to the power 4. Rate of change just means differentiate. So, bring your power down, multiply the number at the front, do all your stuff like that, so you get 12x squared, take away, do the same, and then if you want the rate of change at -1, all we need to do then is substitute -1 into your formula to get your final answer. Question 5, here's the circle. Now it says P has a point 32, so let's call this point here 32. And it also says that Q has the point 72, so let's call this point here 72. Now if we want the equation of a circle, remember the answer is going to be written as x minus a squared plus y minus b squared equals r squared. We need to know two things in this formula. We need to know the centre, which is your a and b, and we need to know what the radius is. Okay, so looking at the back of our diagram, the centre, oops, my pen's not working, yep, the centre here is just halfway between these 2 points. So you just look at these 2 points, get the halfway between, and then plug those numbers into this formula. How are we going to work out the radius? Well, once we know what the centre is, we can then automatically work out what that distance is, and that's going to tell you what the radius. Now remember, you need to work the radius out. Do not leave it as something squared. Work it out. Question 6. The vectors are perpendicular, so that means when you do the dot product, you should get 0. So we do 1 times -5, add 2 times 2, add 4 times z, and that's got to be 0. So you just solve that equation and you'll end up with z equals something. Okay, the longer questions. Question 7. Find the equation of the median BD. So a median is a line that cuts the other side in half. So the process for this is to find the midpoint. My pen decides not to write on me. So find the midpoint. Now the midpoint is where you add the x numbers together in half, and you add the y numbers together in half. So you take point A, you take point C, put them through that little formula, and you get the midpoint, which is D. Once you've got the midpoint, the next thing you're going to work out is the gradient of BD, because you now know what this point here is, you know what this point here is, so you can get the gradient of that line. Once you've got the gradient of that line, you can then simply put both of these things into y minus b equals mx minus a. For 7 part B, you've got to calculate the altitude. Obviously I've had a bit of problem spelling this morning. Altitude AE. So an altitude is a line that makes 90 degrees with the other side. So nothing at all to do with midpoints. Altitudes are nothing to do with midpoints. So the first thing we're going to do is work out the gradient of BC. That's a C. Once we've got the gradient of BC, then we'll work out the perpendicular gradient. Once we've got the perpendicular gradient, we're going to use point A, and we're going to plug that in to y minus b equals mx minus a. The last part of the question, the intersection, take both your lines, whatever they might be, and then just perform simultaneous equations on them. I'm not going to go through that with you. And it comes out to be a nice wee simple answer. There's no fractions involved at any place. Question 8, the wave function. Just been doing them in class. So take your k cos x minus alpha and write it as k cos x cos alpha plus k sin x sin alpha. Okay, now remember the two bits that we're looking for. We're looking for what does k sin alpha look like, what does k cos alpha look like. So checking over here, there's my k sin alpha, that's beside the sin x. So here's the sin x here, so what's beside the sin x? Oh, lo and behold, it's a 5. You can do the same process, k cos alpha, there's my cos, and my k. What's it beside? It's beside cos x. What's beside cos x? Oh, it's 3. Once you've identified both of those, it should be easy to work out what k squared is, and then get k, and then it should be easy to work out what tan alpha is, and then get alpha. Part of the question, find the solution when it equals 4. So once you've done the first part of the question, let's just say, for example, you got it to be root 34 cos x minus, oops, okay, I'm going to have to abandon the pen, x minus 59, and you've got to put that equal to 4. Okay, so what you're going to do now, you're going to take the root 34 over to this side, which means there's going to be a divide. So you then have cos x minus 59 equals 4 divided by root 34. Go into your all sine tan cos diagram. Cos being positive would be here and here. So on your calculator, you work out what the angle is. So you have x minus 59 equals your angle here, and it also equals the angle here in the C box. Then all we need to do is take the 59 over, and we've got x equals for your answer. The only thing I will say for this question is a wee sting in the tail, because the question says that it's only allowed to exist between 0 and 90. So make sure your answer is between 0 and 90. Last question is really just a big, horrible, nasty algebra question. We've got a straight line and we've got a circle, and we need to work out where they cross basically. So how do we do that? Simultaneous equations. How we do simultaneous equations on this sort of stuff? Substitution. So the first thing I'm going to need to do is I'm going to have to take the straight line and rewrite it as y equals k minus 2x. And it's probably best to write it like that. Now I'm going to substitute my k minus 2x in here. So I'm going to end up with x squared plus k minus 2x squared minus 2x minus 4 equals 0. Now you need to remove all the brackets, tidy it all up, and a couple of lines later you'll have something x squared, you'll have something x, you'll have something which equals 0. Okay, and once you've got all of that, because the question says it's a tangent, we're trying to make b squared minus 4ac equal to 0. So you take your b, which is this thing here before the x, and stick it in here. You take your a, which is here, stick it in there, and you take your c, which is here, and stick it in there. Okay, and then after a wee while, you've done all of that, you'll end up with two brackets, or sorry, first of all you end up with an expression which is equal to 0, which you can then put into two brackets equal to 0, which will give you two values for k. You'll get k equals and k equals. But the question said that k had to be bigger than 0. So one of these is going to be ruled out. Okay, there's a lot of algebra, but it actually factorises quite easily. Part of the question, once you've actually worked out what k is, and let's just say for example it happens to be k equals 7, then you substitute that back into your initial expression. Okay, so your initial expression, which was x squared, wait a minute, I'll need to find it if I've lost it. Yep, x squared plus k minus 2x all squared minus 2x minus 4, sorry I'm trying to read two things at once here, equals 0. Okay, you put 7 back in there for that, tidy all the brackets up, work it all out, you should end up with x equals a nice wee simple number. Okay, there's probably at least a page of algebra in that question, guys. It's a bit of a monster. But if you can do the ones up to that point, you're doing well. If you can get anything at all in that question, then superb. Right, hopefully that'll give you a wee bit of help this week.